I'm the Director of Product Marketing at Digix for the broadband infrastructure product lines. And I'd like to thank the kind folks at Richardson RFPD for inviting me to speak today about power amplifiers for small cell wireless infrastructure applications. Brief introduction to Digix. We've been providing RF solutions for over 25 years into the cable TV and wireless communications industry. We focus on products with higher performance, higher bandwidth, higher linearity, and we are focused on today on markets such as 3G, 4G cellular handsets and smartphones, other mobile broadband devices, wireless infrastructure and small cell applications, which I'm speaking to you about today, cable TV infrastructure and subscriber products, as well as Wi-Fi, WiMAX enabled notebooks and handsets. We are headquartered in New Jersey in the United States. So the increasing demand for mobile data has been driving a change in cellular networks. Whereas before the focus was on high mobility and voice-centric applications, we're seeing a shift to higher capacity data-centric applications. And those requirements are driving a different kind of need for power amplifiers for this market space. Some of the requirements and benefits of such amplifiers include the capability to support data offloading, the use of more indoor connections, and the forecast for that is that 65% of mobile data usage will be indoors. Some of the benefits to operators for these kind of applications can be zone-based applications that will increase operator revenue. Some of the requirements are for these infrastructure applications to be installed more quickly and maybe make use of self-optimized networks. You want these networks to be lower cost, and one way to do that is to make better use of your spectrum by filling it in spatially rather than acquiring new spectrum. For the consumer and the user, they'd like to see better performance, perhaps better quality of service, and enhanced coverage. So places where they don't normally get good reception or can't get high-speed data, they'd like to have that very prolific. So as we look at this view of what the market needs to do, we can sort of space out a set of requirements for power amplifiers to address these needs. So some of the different aspects of power amplifiers that are important are the linearity, and in particular the ACPR performance, the power efficiency of the amplifier, so that you're not using too much power, or you're lowering your cost for power consumption, as well as making it easier to do the thermal design. Good long-term reliability. So because these are infrastructure applications, you don't want to incur the cost to go out and have to do repairs or replacements in the field. And we also see with the advent of the small cell infrastructure that the volumes are a little higher, and the business model will probably move from OEM supply to ODM supply, which means that there'll be more contract manufacturers doing the designs, and so what we'd like to do is make the product that's easy for those designers to incorporate in without having to do a lot of special pay attention to RF techniques. So regarding linearity, low EVM is a given, not necessarily as stringent as for some types of systems, but there's still a requirement for the wideband CDMA, and LTE to have minimum EVM performance, but the driving factor is really adjacent channel power rejection. And in particular, because these are downlink applications, the requirements are a little more stringent than they are for handset applications. And so you want to be sure that not only are you supporting a system level requirement, but you have some margin, because there's going to be degradation from the rest of the transmit link. You'd like to have these products tested to the specific waveforms that are going to be used. So TM1 specs for wideband CDMA or ETM 1.1 specs for LTE standards. And all this will be meant to support higher data rates, maximize channel utilization, and increase the number of users that can be supported from any particular base station. As an example, the new line of power amplifiers that Anadigix has been developing for these applications support ACPRs in the range of -47 to -50 dBc at the rated output power levels for both wideband CDMA and LTE waveforms. You also would like to have as good power efficiency as possible for these applications. And the things that power efficiency buys you are cost-effective power supplies, less complex thermal design, and that enables you to do smaller layouts. The type of architecture that you use for the power amplifier is important. In the case of the products that we've been developing, we've been using advanced Class A/B designs. Those provide an advantage over traditional Class A designs in that at the rated output power, you're going to consume less current and be more efficient, particularly in the output stage. So as an example, for 24 dBm or quarter watt out of the PA, you might consume 700 milliamps from a Class A design, but you might consume only 400 milliamps from a Class A/B design. And then in addition, with the Class A/B design, as you back off the drive level, your current consumption will decrease. So the net benefit is, regarding efficiency, you will have a marked improvement in power efficiency, not only at the rated output power where the device will be operating most of the time, but also at backed off output powers where the device is also operating at some time. And even at back off, it's important that your linearity is not degraded, so you want to be able to maintain the ACPR performance at the lower power levels, same way as you did at the rated output powers. So the products that Anadigix have been developing are advanced Class A/B designs with very good power efficiency. In some cases, the power efficiency is twice that of your conventional PA that's available. And we maintain the good linearity and performance at the backed off output powers as well. Because it's an infrastructure application, you do need good long-term reliability. You want to minimize the failure rate. You want to reduce network downtime. You want to minimize the cost of maintenance and repairs. One way you can do this is to make sure that you're maintaining lower junction temperatures in your device. So as an example, for gallium arsenide, 150 degrees Celsius is commonly recognized as a danger level for the junction temperature of the device. And in the case of the Anadigix designs, we're typically operating at about 120 degrees, which is plenty of margin where you won't be concerned about reducing the long-term reliability of the device. And as I mentioned earlier, in order to ease the use of design, of incorporating the product into a design, you want to have a solution that's very easy to use, doesn't require a lot of external tuning. And Anadigix has accomplished this by including all of the RF matching within the package. So both the input and the output of our new wireless infrastructure power amplifiers are 50 ohm matched, don't require any external tuning components, just some standard bypass capacitors on some of the supply and control lines. And we've put everything into a relatively small 7x7 millimeter package, which is common throughout this family of products. And in almost every case, the products are pin compatible with a few minor exceptions. So Anadigix has really gone to great lengths to make sure that the power amplifiers that we develop for these small cell wireless infrastructure applications are very easy to use. Almost just drop it in and go, no performance degradation. You just have to be a little careful on thermal design, but not nearly as much so as you would have to be with a Class A product. Just taking a quick view at the offerings that Anadigix is developing for this small cell infrastructure space. We have a family of products that are plus 24.5 dBm of rated linear output power, and another group that's plus 27 dBm. So that's quarter watt and half watt designs. Those will typically support 100 milliwatt or quarter watt outputs at the antenna, given the typical losses between the PA and the antenna for most femto cells or pico cells. So we've got a variety of products focused on being tuned for the different frequency bands. They're in various stages of development right now. We have about 4 products that are fully qualified for production. We have some that are shipping to customers already. We announced last week our 2 Band 5 products, which are now available for sampling. And we're continuing the development with products for Band 8 and the 700 megahertz frequency bands. And we may add other products as required for the market space or based on customer interest. So what Anagigix has strived to do is develop products that are innovative, best in class, meaning high performance standards, high quality and reliability standards, achieving very good linearity and ACPR performance, very high efficiency for low power consumption, very high levels of integration for ease of use. So thank you for your attention, and if anybody has questions, I'm happy to field them.